नमस्कार मेरे यूट्यूब के सभी स्टूडेंट्स, बहुत बहुत स्वागत है आप सभी का फिर से हमारे चैनल मैथ्स विद सुड में। आज हालांकि मैं केमिस्ट्री की क्लास ले रहा हूँ। केमिस्ट्री की तीसरी क्लास है। शुरू की दो क्लासेस के वीडियो आपको लिंक में दिख जाएंगे। आप पीछे की वीडियोस में जाके देख सकते हैं। अभी तक हमने जो कुछ भी पढ़ा है, मेरे साथ क्लास में मौजूद हैं आद्रिजा एंड सानवी, जो कि बहुत ही इंटेलिजेंट बच्चे हैं। तो फटाफट से हम रिवीजन कर लेंगे और इसको आगे बढ़ाएंगे। तो मैटर इन आवर सराउंडिंग्स में हमने पढ़ा था मैटर इज़ मेड अप ऑफ मास, मास इज एन मैटर इज मेड अप ऑफ मैटर। मैटर क्या होता है? एनीथिंग दैट ऑक्यूपाई स्पेस एंड हैव मास इज नोन एज ए मैटर। फिर मैटर की हमने एक फिजिकल नेचर पढ़ा था, मैटर इज मेड अप ऑफ पार्टिकल्स। फिर पार्टिकल्स की हमने कैरेक्टरिस्टिक पढ़ी थी, क्या क्या थी? उनके बीच में स्पेस होती है, वो कंटिन्यूसली मूव करते हैं, दे आर अट्रैक्टिंग, वो एक दूसरे को अट्रैक्ट करते हैं और वो बहुत छोटे छोटे हो जाते हैं। ऐसे करके बहुत सारी एक्सरसाइजेस हमने पढ़ी थी, कुछ क्वेश्चन आंसर्स हमने किए थे। फिर हमने फिजिकल स्टेट्स ऑफ मैटर पढ़ा था, उसमें सॉलिड स्टेट, लिक्विड स्टेट और इनकी प्रॉपर्टीज़ पढ़ी थी डिपेंडिंग अपॉन इसके अंदर कैसे कैसे पार्टिकल्स होते हैं। आज की क्लास में हम कोशिश करेंगे इसी चैप्टर को हम आगे ख़त्म करें। बहुत सारी एक्सरसाइज, बहुत सारे इसमें अलग अलग करेक्टरिस्टिक्स के लिए लॉजिक्स हैं, प्रूफ्स हैं और इसी के आधार पर क्वेश्चंस हैं। तो आज हम लास्ट क्लास में हमने लेटेंट हीट के बारे में पढ़ा था, लेटेंट हीट ऑफ फ्यूजन, लेटेंट हीट ऑफ वेपोराइजेशन भी हमने पढ़ा था। हालांकि बुक में उसकी डेफिनेशन दी नहीं थी, लेकिन हमें बताया गया था कि हम कैसे उस डेफिनेशन को बनाएंगे। तो चलते हैं फटाफट से इस चैप्टर को ख़त्म करते हैं। कैन मैटर चेंज इट स्टेट्स हम पढ़ चुके हैं, पेज नंबर 8 तक हमने पढ़ लिया था, यहाँ पे हम थे। ओके, You must have observed during the experiment of melting that the temperature of the system does not change। और यहीं पे हमने लेटेंट हीट के बारे में पढ़ा था। केल्विन का रिलेशनशिप भी हमने देखा था कि 0 डिग्री सेल्सियस में 273 केल्विन होता है। बच्चों ने पूछा था कि सर ये केल्विन कहाँ से आ गया, तो मैंने इसलिए बताया था क्योंकि बहुत सारी कैलकुलेशंस जब होती हैं, हम केमिस्ट्री में भी मैथ्स घुसाते हैं, तो न्यूमेरिकल्स जब होते हैं तो वहाँ पर अगर हम हर जगह जीरो ले लेंगे तो जीरो की खास बात होती है कि उस सभी नंबर्स को मल्टीप्लाई करके ज़ीरो बना देता है और इस कारण से हमारे क्वेश्चन सॉल्व करने मुश्किल हो जाते हैं। तो हमने एक नई टेम्परेचर की यूनिट लेके आए, 27 केल्विन। और केल्विन का जो रिलेशनशिप होता है जस्ट सिंपल एडिशन है। शुरुआत उसकी 0 डिग्री सेल्सियस 273.15 केल्विन होता है। हालांकि 0.15 हम अभी छोड़ दे रहे हैं, इतना छोटा नंबर है, उसके मायने नहीं है। हालांकि आगे चल के हम जरूर करेंगे उसको। अब देखो 273.16 केल्विन लिखा है यहाँ पे। केल्विन इज द एसआई यूनिट ऑफ टेम्परेचर। आपसे क्वेश्चन पूछा जा सकता है विच ऑफ द फॉलोइंग इज द एसआई यूनिट ऑफ टेम्परेचर। उसमें ऑप्शन आ जाएगा केल्विन, फ़ारेनहाइट, डिग्री सेल्सियस या फिर कैलोरी। तो तुम लोग क्या करोगे, उसमें केल्विन पे क्लिक करोगे, ठीक है। फॉर कन्वीनियंस वी टेक 0 डिग्री सेल्सियस इज इक्वल टू 273 केल्विन। कन्वीनियंस, आसानी के लिए, आफ्टर राउंडिंग ऑफ द डेसिमल टू चेंज टेम्परेचर ऑन द केल्विन स्केल, सेल्सियस स्केल, यू हैव टू जस्ट सब्ट्रैक्ट 273 फ्रॉम द गिवन टेम्परेचर। जो भी टेम्परेचर है उसमें से 273 सब्ट्रैक्ट कर देना है। एंड टू कन्वर्ट द टेम्परेचर ऑन द सेल्सियस स्केल टू केल्विन स्केल, यू हैव टू ऐड। सेल्सियस से केल्विन पे जाना है तो ऐड करना है, केल्विन से सेल्सियस पे आना है तो सब्ट्रैक्ट करना है। बहुत ही सिंपल है। ओके, चलो एक एक्टिविटी देखते हैं। आद्रिजा रेडी, सानवी रेडी? ओके, so the activity is 1.13, the page number 8. Today we will finish this chapter. Okay, take some camphor and ammonium chloride, crush it and put it in a china dish. Put an inverted funnel over the china dish. Put a cotton plug into on the stem of the funnel as shown in figure 1.7. ये अमोनियम क्लोराइड है, इसके अंदर अमोनियम क्लोराइड सॉलिडिफाइड है। ये यहाँ पे इन्वर्टेड फनल है, यहाँ से बर्नर से चाइना डिश को हमने हीट करना शुरू कर दिया। अब क्या होता है जब हम हीट करते हैं? Now heat slowly and observe. What do you infer from the above activity? A change of state directly from solid to gas without changing the liquid state or vice versa is called sublimation. Definition है, फटाफट से लिख लो। A change of state directly from solid to gas. ठीक है, स्टेट चेंज हो रहा है, लेकिन कहाँ से हो रहा है? सॉलिड से सीधा गैस में हो रहा है, लिक्विड आ ही नहीं रहा। विदाउट चेंजिंग इनटू लिक्विड स्टेट और वाइस वर्सा, वाइस वर्सा मतलब उसका उल्टा भी, is called sublimation. लिख रहे हो तुम लोग?
यस सर। यस सर।
बोल बोल के लिखो बेटा, मुझे पता तो चले कहाँ पे हो तुम लोग। A change of state directly from solid to gas without changing into liquid state or vice versa is called sublimation. तो हम लोगों ने देखा कि हीट के इफेक्ट से, अभी तक हमने क्या पढ़ा, हीट के इफेक्ट से हम किसी का भी स्टेट चेंज करते हैं. जब हम उसमें काइनेटिक एनर्जी डालते हैं तो उसके अंदर जो छोटे छोटे पार्टिकल्स होते हैं उनकी एनर्जी स्ट्रांग हो जाती है, जिसकी वजह से उनके बीच में जो फोर्स ऑफ अट्रैक्शन होता है उसको वो ओवरकम करके सॉलिड से लिक्विड में कन्वर्ट हो जाते हैं और ऐसे ही लिक्विड से फिर गैस में कन्वर्ट हो जाते हैं. गैस में मैंने बताया था नशे में रहते हैं, भागते रहते हैं, दीवार से टकराते हैं और वापस टकरा के बैठ जाते हैं. मैं चाहता हूँ कि मेरी क्लास में आद्रिजा एंड सानवी दोनों बहुत ही खूबसूरत बच्चे अपना अपना कैमरा ऑन कर लें. मैं आप लोगों को देखना चाहता हूँ. यूट्यूबर्स को नहीं दिखाऊंगा, तुम लोग को मैं एटलीस्ट देख लूँ. दोनों का कैमरा बंद है, मुझे पता ही नहीं चल रहा तुम लोग पढ़ रहे हो कि नहीं पढ़ रहे हो. यस, वेरी गुड आद्रिजा. आद्रिजा का बैकग्राउंड भी बहुत मस्त है, ऐसे लगता है पढ़े लिखे घर से. पीछे पूरी लाइब्रेरी दिखती है.
Sir, we have to go to her. You have to go to her house. Only books.
ओके.
Those are not my books.
Her father's and her mother's.
अच्छा, वो भी पढ़े लिखे हैं क्या? आर दे ऑथर?
Yes, sir. No, sir, not author
No.
exactly.
फिर दे आर बुक रीडर.
One of them just loves reading novels, and the other one was, well, addicted to books, I guess.
Yeah.
Then
Her
who-
father is addicted to books.
So one is addicted to book, one is just love reading novels. So who is earning to bring those books into the home?
Well, actually, in different ways, both, I guess.
Yeah.
Okay.
Like, the actual earner is my father, but in other ways, my mom also earns.
Okay, so she must start doing storytelling on the YouTube, you know. That's she is reading so much of novels. So what she can do is she can just tell a story of any. There are so many
Yeah,
audiobooks.
actually, she can. I'll
Yeah,
tell
we
mom.
can give auntie
And
idea
there are,
today.
you know what, there are so many audiobooks on this base only. We don't want to read anything, we want to listen to somebody. The main thing is she must know how to do voice acting. Means if she is telling, narrating a story, it should be in a different tone, not like boring just reading the book. Okay, she
So
has
you
to.
can ask
Auntie
Sanvi
is
also. My
great
mom
in
does
that.
all of that.
Auntie is great in that.
Okay. So I'll ask her. I will create her YouTube channel as well. Don't worry. Okay, so let's start. So we have heat. So we have learned the effect of pressure. Okay, we learned the effect of heat. Okay, this is what we were being told in the first part. Ki how a matter changes states. Now, Adrija, your question was ki can pressure do the same thing, right? In the last class, I told you about the LPG, liquefied petroleum gas. Because of those high pressure, the gas is converted into liquid. Now you can say here as well. So effect of change in pressure. We have already learned that the difference in the various states of matter is due to the difference in the distances between the constituent particles. Okay, the basic difference. Why it is a solid? Because it is hard. No, don't say like that. Why a liquid is a liquid? Why water is a liquid? Why ice is a solid? Why water vapor is a gas? So a particular state of any matter is because of the main thing, because of the distances between the constituent particles. The more is the distance, the more are their movement and more they are free to move, and same goes with the kind of state that they are in. If they are more closer, they are solid. If they are more spacious, they are flowing, then they are liquid, and they are more spacious, then it is a gas. What will happen when we start putting pressure and compress a gas enclosed in a cylinder? Now you think of yourself, okay? You think of yourself as a gas particles. Now you are just randomly, there are so many gas particles of your body and they are just running around in a room. Now suppose somebody comes and squeezes that room. The size of this room is shortening from all the corners. Now what will happen? All the particles that they are roaming around will come closer to survive, right? They cannot go farther now. So they will come closer, and a point will come when again all the particles will join together and again you will become Adrija. Okay, so Adrija in a liquid state, not in a solid state. But if the pressure is more and more, and suppose you are being made a very small point, so then you will become solid as well. Are you getting it? So the more spacious that you have been given, the more space that you are being given, the more free you are to move, and that kind of matter that you are in. So you can imagine in your mind that if pressure is increasing, the state will be more closer to the forces of attraction, like that. So which is the most closest force of attraction apart from gas? Gas does not have a force of attraction, so we can condense it to liquid. Are you getting it?
Yes, sir.
Wonderful.
So, but in theory, it should be possible to like just before obtaining gas, that stage. It's not gas. Just before obtaining liquid, that stage.
That stage just before obtaining liquid.
Yes, sir.
I cannot imagine that state. Means it is a state of equilibrium. At the same time, since you see the temperature is also not changing, so a part of it is changing into, so you want to say it is a semi liquid or semi gas, like that.
Yes, sir. Like
Since I haven't seen those stages, so I cannot comment on them as well. Okay, the thing is that see, what we can feel, what we can experience, what we have seen through our five senses only, then only we can say something about it. Since I haven't experienced anything, means I have to be in that part where a particular thing is being happening, then I can say, I will just figure it out if there is anything like that or not. But as of now, I don't know anything about it, or it could have come in a star mark. Books are being updated as well. So do you think that
And
increasing
so-
or decrease? Yeah, tell me.
And so, like, slime, is it solid or liquid?
Slime.
Yes, sir. Like, it takes the shape of the container it is put in.
Lime
And
or
it's
slime?
not slime, SLIME.
What is that slime? I haven't heard of that.
Uh, it's, how can I explain it?
You cannot explain, you don't worry. I will just see it on Google. Okay.
Slime is like a glue mixed with some things, and it's like a bit sticky type.
Slime
doesn't
was a
have to be
toy
sticky.
product manufactured
yeah,
by
it's a
metals.
stretchy,
Sold in
stress
a plastic
reliever.
trash, can be introduced in February 1976. It consisted of non-toxic viscous.
It's
So I
Okay.
guess you can go to the images and videos or
Yeah,
something.
it's a stretchy, stress reliever. We can just
It doesn't have to be sticky though.
stretchy.
Yeah, stretchy.
Yeah.
Okay, so slime is a non-Newtonian liquid, which means that the viscosity or resistance of the liquid changes as you apply the stronger force. If you rest your hand on the surface of slime, it will sink in, but if you snack at the surface, okay. Okay, I have
Yes,
seen
so
those.
basically slime is something between solid and liquid, right?
No, it is non-Newtonian liquid.
So
Now you must be knowing what is non-Newtonian, what is Newtonian liquid, what is non-Newtonian liquid. So these are just different names. The thing is that you are new to this, you are new on this earth. So we are just going by the convention that our scientists have told us. So once you will become, one day you will also become a scientist. So we can say non-Adrija, Adrigenian liquid, something like that. Okay, right now what you are imagining is, see, a particular thing, see, there is a situation in life. On the situation there may be something happening at a different levels with the situation. So they are telling that what is happening with the lime. I have seen so many reels now. I remember that there is a bowl, in that lime is there. Somebody just keep on hitting and it is acting like a solid, and once you place your palm very gently, it will just sink into the liquid. So it is a kind of liquid only. So they are selling non-Newtonian liquid. So it is a kind of liquid, but once you apply the pressure, the viscosity, and you know what is a viscosity? Viscosity of a liquid means the force of attraction between the liquid, how well
basically
the
how
liquid will
thick
flow.
it is.
What?
Basically how thick it is.
How thick it is, you can say like that.
Yeah.
In a layman language, you can say how thick it is. Okay, so viscosity keeps on changing as soon as you change your pressure. Okay, viscosity is changing. They are telling that if you rest your hand on the surface, Viscosity and resistance also changes. Resistance, you know what is resistance? The tendency to uh, resist the motion. Resistance means if somebody is moving, resistance means they are not moving, they are resisting to the act. So the resistance and the viscosity changes with the pressure. So it is acting like a solid, but it is non-Newtonian liquid. If somebody asks you what is a lime, you will say non-Newtonian liquid. Newtonian is a name given on the basis of the scientist Sir Isaac Newton. Do you know that? Sir Isaac Newton, okay. Isaac Newton is a great physicist, great mathematician, physicist. You can tell him anything. The great law of gravitation, attraction, the three laws of motion, all given by Newton only. Okay, Sir Isaac Newton. There is a Sir given to that person. I also honestly love him. He is a very great scientist. So non-Newtonian liquid means on the basis of his own name, it was given like that. Okay, I will just come to that, but before that I would like to finish this chapter. All these discussions we can keep it aside. Okay, chalo. So do you think that increasing the or decreasing the pressure can change the state of matter? In your mind, what can happen if you are increasing the pressure? The particles are becoming more closer. So what will happen? You can see this piston cylinder. Once you are pressing it, the more pressure is applied, so it will become a liquid. It can become a solid. By applying the pressure, particles of matter can be brought close together. Applying pressure and reducing temperature can liquefy gases. Okay, simultaneously you are reducing the temperature as well. Have you heard of solid carbon dioxide, CO2? It is stored under high pressure. Solid CO2 gets converted directly to gaseous state on decrease of the pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. Please write it down. You write from here. Solid CO2 gets converted directly into gaseous state from here. Solid CO2 means carbon dioxide. Solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere. लिख रहे हो तुम लोग कि बस हंस रहे हो?
सब highlight कर रहे हैं.
What? You want to just highlight? You want to write later on?
Sir,
Yes, sir, we are
it's highlighting.
Okay,
just
just let me know. Okay, fine. It's okay. You just highlight them. Okay.
Yeah.
Thus we can say.
Did something weird.
No, someone we came in between the class. So
Okay. Who came? I didn't saw anybody.
my sister.
Okay. So this is the reason that solid carbon dioxide is also known as dry ice. You will be given a question why the solid CO2 is known as a dry ice. So you can say that the solid carbon dioxide gets directly converted into liquid state with gaseous state without becoming into liquid state on the decrease of pressure to 1 atmosphere. So it is under a high pressure. Once you release the pressure to 1 atmosphere, so it will directly convert into gaseous state. Now see this, please make this diagram. This you should make. Very
So
simple.
like how it can be done with like carbon dioxide can also be done with oxygen?
No. See, the thing is that chemistry is full of experiment. If somebody has done the experiment, it will be noted here. I can just say it out, but since I have not done it, I am not reading it as well, so I don't know about O2. Different gases, different properties, different characteristics. Okay, so I'm not sure of O2, but I'm sure of CO2. Please make this figure liquid. So from gas to liquid, the process is known as condensation. From liquid to gas, the process is known as vaporization. From solid to gas, the process is known as sublimation. From gas to solid, it is also known as sublimation. I want you to check it in your notebook, in your book, textbook. I think it is not anymore sublimation. The name is different now.
It is deposition.
Deposition, yes, write it down.
Yeah.
Deposition. Make the figure of your textbook now. This is an old textbook. I have to update
I
this.
have my textbook here, so I'm just.
Yeah, last year also I taught one of my students, so I remember that. It is not sublimation anymore, it is deposition.
Deposition, yeah.
Then from solid to liquid, it is known as fusion, and from liquid to solid, it is known as solidification. So you can do solidification by reducing the temperature and increasing the pressure. Done?
Yeah.
Okay. Let's learn this as well.
Ilba?
So 1 atmosphere ATM is a unit of measuring pressure exerted by a gas. The unit of pressure is Pascal. What is that? Pascal. And it is written like capital P small a. 1 atmosphere is equal to 1.01 into 10 to the power 5 Pascal. The pressure of air in atmosphere is called atmospheric pressure. The atmospheric pressure at sea level is 1 atmosphere and it is taken as the normal atmospheric pressure. Alright. So while solving questions, sometimes you have to take it as a 1.01 into 10 to the power 5 Pascal. Okay. I want you to do this question as quick as you can. Convert the falling temperature to degrees Celsius. Tell me for the first one. Who is going to tell me first? What do you have to do from Kelvin to degrees Celsius? If you want to go, what do you have to do? You
So
have
you have
to.
to subtract to 73.16.
So how much degrees
Or just to
Celsius?
73.
Uh,
It'll be 27 or 26.8.
No.
4.
27 only. Okay. What about the second one?
So,
573 Kelvin.
which would be
300 degrees Celsius.
yes, sir.
Okay. 300 degrees Celsius. Okay. Now what is the physical state of water at 250 degrees Celsius? Tell me. What is the physical state of water at 250 degrees Celsius?
So it is gaseous state.
Okay. What about B, 100 degrees Celsius?
It is vapor.
It's
Oh, wait.
vapor. It's like it'll also be gaseous, I guess.
Vapor,
No,
right?
it is no.
Yeah,
No. At 100
Be
degrees
liquid?
Celsius, it is also solid. Sorry, it is
Okay.
liquid as well as vapor. Both. It exists in both the
So
states.
it will be liquid also and vapor.
Yes.
Yes, sir.
For any substance, why does the temperature remain constant during the change of state? Because of the latent heat. Okay, this is a very short answer, because of the latent heat. But we can say that during the change in state, what happens is lot of heat is being given to overcome the force of attraction between the particles. Okay, so the heat that we give during the change of state is being taken away, is being hidden in the form of latent heat. So there is no change in the temperature. So temperature remains constant. Are you getting it? The answer is given in the book itself.
Okay.
Suggest a method to liquefy atmospheric gases. So you can reduce the temperature and increase the pressure.
Pressure.
Wonderful.
Reduce.
Evaporation. Very simple. I want you now to read. Who is going to read? Adrija, please read it. And read it like
Yes, sir.
that you are narrating it. Don't read it like bluntly.
Sir,
Okay?
reduce temperature and increase?
Increase pressure, beta.
Okay.
Evaporation. Do we always need a heat or change pressure for changing the state of matter? Can you quote some examples from everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? Water, when left uncovered, slowly changes into vapor. Wet clothes dry up. What happens to water in the above two examples?
Okay, very good. So there is a question in your textbook as well, how wet clothes are dried up. So because of the evaporation, okay, water keeps on going away. In fact, if there is no boiling point as well, if it is uncovered, it keeps on changing its state. Okay, read from here.
Yes, sir. We know that particles of matter are always moving and are never at rest. At a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy. In the case of liquids, a small fraction of particles at the surface having high kinetic energy is able to break away and from forces of attraction of other particles and gets converted into vapor. This phenomenon of change of a liquid into vapors at any temperature below its boiling point is called evaporation.
Highlight this. From where you will highlight?
Where?
At a given temperature. Okay? From here.
Okay.
From up to here. If somebody asks you what is evaporation of 1 or 2 marks, So if they are asking for 1 marks, you can say the phenomena of change of a liquid into vapor at any temperature below its boiling point is called evaporation. If it is a question of 2 marks, then from here you have to write. At a given temperature in any gas, liquid or solid, there are particles with different amounts of kinetic energy. And in case of liquids, a small fraction of particles at the surface having higher kinetic energy is able to break away from the forces of attraction of other particles, and they get converted into vapor. Are you getting it? This phenomena of change of a liquid into vapors is at any temperature below its boiling point is called evaporation. Very good. Well done. Okay. Factors affecting evaporation. Okay, now it applies only common sense. You can tell me from your own experience. So tell me, if I increase the temperature, will the evaporation will increase or not?
Yes,
Yeah.
sir.
Yeah.
Think about winter season and summer season. So when are the clothes get dried up?
When evaporation takes place.
When there is a high temperature. Okay, evaporation increase when there is a high in temperature. Okay, so take 5 ml of water in a test tube and keep it near the window or under a fan. Take 5 ml of water in an open china dish and keep it near a window or under a fan. Take 5 ml of water in an open china dish and keep inside a cupboard or on a shelf on your class. Record the room temperature. Record the time or days taken for the evaporation process in the above cases. Repeat the above 3 steps of activity on a rainy day and record your observations. What do you infer about the effect of temperature? Surface area and wind velocity on evaporation. So when the surface area increases, so evaporation is happening because the particles at the surface of the liquid which are having higher kinetic energy can overcome the forces of attraction. So those forces of attraction can be overcome if the temperature is high, if the surface area is high. Are you getting it? Suppose you have a big bucket, the more amount of evaporation will be there. If you have a small tumbler, the less amount of evaporation will be there. Now surface area and wind velocity. So as there is a more wind velocity, what will happen? It will increase the kinetic energy. It will keep on making the vacuum just above the place where the evaporation is taking place. It will take away those water vapor and again the water vapor will come up. Are you getting it? So there are only 3 things: temperature, surface area and wind velocity. So if anything is increasing, the evaporation is also increasing. You must have observed that the rate of evaporation increases with. So first point, highlight an increase of surface area. Evaporation increases, rate of evaporation increases with an increase in surface area. We know that evaporation is a surface phenomena. If the surface area is increased, the rate of evaporation increases. For example, while putting clothes for drying up, we spread them out. An increase of temperature. With the increase of temperature, more number of particles get enough kinetic energy to go into the vapor state. A decrease in humidity. So evaporation increases if the humidity is decreased. See how? So humidity is the amount of water vapor present in the air. What is humidity? It is the amount of water vapor present in the air. If the humidity is 100%, there will be a rain. If the humidity is 100%, we will say that there is a rain.
Okay.
The air around us cannot hold more than a definite amount of water vapor at a given temperature. If the amount of water in air is already high, the rate of evaporation decreases. So with the humidity decrease, the rate of evaporation increases, but with the increase in humidity, the rate of evaporation decreases. An increase in the wind speed. It is a common observation that clothes dry faster on the windy day. With the increase of wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. How does evaporation cause cooling? In an open vessel, the liquid keeps on evaporating. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surrounding makes the surroundings cold. Did you understood? Very easy concept.
What happens when you pour some acid on?
Yeah, read it louder, beta.
Okay. What happens when you pour some acetone nail polish on your palm? The particles gain energy from your palm or surroundings and evaporate, causing the palm to feel cold. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water helps to cool the hot surface. Can you cite some more examples from your daily life where we can feel the effect of cooling due to evaporation? Why should we wear cotton clothes in summer? During summer, we
Highlight as well.
perspire.
Highlight as well.
This question, sir.
Yes, this question will come as well.
Okay. During summer, we perspire more because of the mechanism of our body which keeps us cool. We know that during evaporation, the particles at the surface of the liquid gain energy from the surrounding or body surface and change into vapor. The heat energy equal to the latent heat of the vaporization is absorbed from the body, leaving the body cool. Cotton, being a good absorber of water, helps in the absorption of the sweat and exposing to the atmosphere for easy
Easy.
vaporization.
Okay.
Yes.
Okay. Why do we see water droplets on the outer surface of the glass containing ice cold water? So please highlight this as well. Let us take some ice cold water in a tumbler. Soon we will see water droplets on the outer surface of the tumbler. The water vapor present in air on coming in contact with the cold glass of water loses the kinetic energy and get converted into liquid state, which we will see as a water droplets. Understood? Very easy logic.
Yes.
Okay, why does a desert cooler cool better on a hot dry day?
Mm. Why does a desert cooler cool better on a hot dry day?
So that's because of the latent heat thing.
Yes. In fact, the what is happening is the more vaporization on a hot dry day. What is happening? It is giving you a more amount of uh, vaporization. Evaporation is happening, and those water droplets that is coming with the air from the cooler will absorb the heat of the surroundings, keeping the atmosphere cool. All right. The better wordings will be given you as a solution in the group. Okay, don't worry. I will give the solution. How does the water kept in an earthen pot matka become cool during summer? Okay, why does your palm feel cold when we put some acetone? So it is already being discussed. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? The surface area, because of the decrease in the surface area. When the surface area increases, keeps on it becomes cool. What type of clothes should we wear in the summer? Okay, cotton clothes. So what will happen now? I am going to open the solution as well. I want you to read the solution so that it goes into your mind. Ninth grade maths 9. No, we are doing science. Exemplar by Jews. Okay, solutions. Atoms, first chapter.
That
Is it the chapter coming or the solution should have come?
chapter, right?
Atoms. This is a chapter or a solution?
I don't know.
Let me see the different software.
Mm. It's just chapter, sir.
How it is a chapter? I don't know how many times I will keep a chapter. I thought it is a solution. Answer. Exemplar by Jews. Science 9th solutions. Yes, this is a solution.
Yeah.
So let's read it quickly, okay? It should not be in a dilemma. Compressibility.
So will you send this also?
Yeah, I will send this.
Okay.
Don't worry. I will send a better version of it.
Yeah. This is just black and white and blue.
Yes.
And in our textbook, black and white.
Then
And orange and
liquids.
reddish purple, yeah.
Okay, so it is
And
like
blue.
Can you see that?
Yeah.
Just now. Okay, so at 100 degrees Celsius, there will be a transition of liquid state into the gaseous state. So at this temperature, the state is maybe liquid as well as gaseous. Okay.
Hmm.
Okay. For any substance, why does the temperature remain constant during the state of change? During the, I want you to read it. Read this. Anyone?
Okay. Which one? Okay. During the change of state of substance, the temperature remains constant. This can be understood with the help of an example. When a solid is heated to its melting point, the temperature first rises and becomes constant when it reaches its melting point. Now, on further heating, the heat energy provided to the substance helps to break the attraction force between the solid molecule. This heat is called latent heat. That is why the temperature does not rise.
Okay. Suggest a method to liquefy atmospheric gases. By applying pressure and reducing the temperature, atmospheric gases can be liquefied. Why does a desert cooler better on a hot dry day? A desert cooler functions on the basis of evaporation. The rate of evaporation increases with the increase in temperature and decreases in the humidity. As evaporation increases when the day is hot and dry, so the desert cooler functions to a better extent.
Better rectangle.
How does the water kept in the earthen pot become cool during summer? So large number of tiny pores is present on the surface of the earthen pot. The water stored in the earthen pot evaporates faster through these pores due to the increased exposed surface area. As the process of evaporation causes cooling, the stored water inside the earthen pot becomes cool.
So, just a question though, if there's so many pores, then wouldn't that mean that the water flows out of it?
No, the pores
Out
are
of the
the
pot.
pores are very small. So there is a pore in your body as well. So does your blood comes out of your body? But you
there's
sweat.
in the
No, but
yes,
you
sir.
do sweat. We not say sweat. We perspire. Okay, only pig sweat. There was a dialogue in a movie. I was I saw the movie Shaurya. So somebody said, okay, माथे पे क्या है तुम्हारे? बोले सर पसीना sweat. बोला only pig sweat man perspire. So here also in the book it is written perspire. Okay. So you do perspire, right? Both of you perspire when you are playing something, you are doing something. So how does the water is coming from your body inside? Do you have a pores on your skin? You do have it, right? So
Yes,
a mosquito can go through that pore and just bite you and suck the blood out of you. Okay? Can he do that? So it is done. So there are pores same like with the earthen pot. So water is not coming out, but with there is a process in which water is just mixing up with the solid, going through it, and there is a sometimes we say कि घर में सीलन हुई है, you know, there is a water on the roof. देन हम लोग देखते हैं कि जो हमारी रूफ है उसमें पानी आ जाता है, धीरे धीरे आता है कि नहीं आता. हम बोलते हैं ना घर सील गया है. किसका अच्छा घर होगा उसका नहीं सीलता होगा, लेकिन किसी किसी का पेंट निकल जाता है. हमने वॉशरूम में टाइल क्यों लगाते हैं हम लोग? सिर्फ इसलिए नहीं कि देखने में अच्छी होती है क्योंकि वो उसको सीलन से बचाती है. नहीं तो जो पानी जाता है ना धीरे धीरे उसका पेंट खत्म हो जाएगा. पानी और हवा कहीं भी घुस सकते हैं, इस बात को ध्यान रखना. ये कहावत है, पानी और हवा अपना रास्ता खुद बना लेते, किधर भी जा सकते हैं, कोई नहीं रोक सकता इनको. तो ये समझ में आ गया पोर्स वाली बात कि पानी क्यों नहीं निकलता है उसमें से. थोड़ा थोड़ा सा निकलता भी है पर पूरा नहीं निकलता है. वाई डज आवर पाम फील कोल्ड व्हेन वी पुट सम एसीटोन और पेट्रोल और परफ्यूम ऑन इट? Acetone, petrol, perfume, etc. being volatile evaporate very fast when exposed to the large surfaces. During the process, they absorb the required latent heat of vaporization from the palm if kept on the palm. So the process causes cooling and palm feels cool. Why are we able to sip hot tea? इसको अद्रिजा पढ़ो फटाफट से, कैसे चाय जल्दी पी लेता है.
A liquid has large surface area in a saucer than in a cup. Thus, it evaporates faster and cools faster in a saucer than in a cup. For this reason, we are able to sip hot tea or milk faster from a saucer rather than a cup.
समझ
So,
में
where
आया?
was the R in this sentence?
Yeah, why was not R in that?
Yeah.
What
I thought
what?
maybe I read it wrong, then I said
Reason,
R,
after that reason, after that there should be R, but there was not
Yeah.
R.
Okay, let me see. A liquid has large surface area in a saucer than in a cup. Thus, it evaporates faster and cools faster in a saucer than in a cup. For this reason, we are able to sip hot tea or milk faster from a
That is
saucer
the
rather
thing
than.
we were telling.
Okay. What type of clothes should we wear in summer? We should wear light colored clothes, cotton clothes in the summer because
Bright color clothes.
light color, yes, not dark. So cotton
Bright.
is a good absorber of water, sweat, no perspire. Only pig sweat. It provides more surface area from the sweat to
To
evaporate.
evaporate.
Light
colours
colors absorb less heat.
Wearing light colored clothes help us feeling cool and comfortable.
So when
So I've heard that light colored clothes even reflect radiation. Is that true?
yes, dark
Oh,
color
so
Then why
dark
not bright
dark
colors?
dark color absorb the radiations, light color reflects.
Why not bright colors like
So when we will understand the topic light, there is a topic light in 10th grade. So when it will come, you will be able to understand that. Okay, right now you are a small kid of 5-year-old, so don't try to ride a bicycle.
we are not 5-year-old?
No,
It's
means
just 1 year difference.
Yeah.
so in the next
1
year
year
there is a lot of difference between 10th grade and 11th grade, 9th grade and 10th grade, and same goes with 11th and 12th. Okay, so a
Nice.
So
small
basically, in the case of a nuclear bombing, if we wear light colored clothes,
What
we'll be
the hell
safe,
is
sort of. Like,
no.
since that's going to reflect the radiation. Like, if
Why?
we stay at a perfect distance away from, well,
So
yeah, the
there
sun.
is an intensity of everything. Okay, anything can be done to some extent. It is not like in a hydrogen bombing or atomic bombing, everything is being vanished. Whether you become a light colored or a dark colored, ultimately you will be no more. That's it. You will be dry ashes.
So, like, if you're like, let's say 15 to 20 kilometers away from it.
So it will be like you will be sublimation of you will be done. Okay, without converting into liquid, you will be directly converted into gaseous.
Oh
If
my
you're like
god.
a particular distance away from it, where the effect is
See,
not
I
that
haven't
high.
experienced it. I have only heard of it, and I want to be far away from it.
Yeah.
So
My
Japan.
question was if it is light, why should only light color clothes be worn? Why can't bright color clothes be worn?
See, light color means the color. Bright color. See, if you are wearing bright colors, nobody is going to question you until unless a dog is going to bark on you. Okay, only that can happen. See, we are in a free democratic India. We can wear whatever we want. You want to wear bright color, parrot color, maroon color, whatever wish you can wear. Why to apply logic and chemistry behind it? Suppose you want to get rid of hot summer season. So it is advised. It is advisory. It is not compulsion. It is advised to wear light color clothes. So it feels good. Okay, it feels good to the people who are at the age of 50 or 60. At the age when you are in, you can just wear any dark or color, any bright color, whatever you want. Okay,
Yeah. Yes.
see, you are more colorful in lives. But at the age of 40 plus, so we just if somebody asks what is your favorite color, we are going to say okay, white or light blue. We'll not say okay, dark black. Somebody can say dark black, but it is not advisable to wear in the hot.
Adri's favorite color.
In fact,
What?
once I
Since when? Come on.
once
I
I
like the color see black with some other color. That'll look good, but just black looks bad.
I know that.
See, because of those black and color combinations in the South India, there was a famous quote that they have got only Sun TV and Surya TV, and because of that,
Oh
everybody is
yeah,
black.
yeah.
Because there is so hot there. In Chennai, when I was in Chennai for the 6 years, I was from 93 to 99, and I can find there was so hot, tremendously hot. So I rarely find somebody fair there. So I found from Kerala, from Bangalore, there are people who are fair, but in Chennai nobody was fair. Everybody was black.
What?
Yes, that's the truth. because because of the demography, it's not because of that pigmentation. Because of the
Yeah, because
demography.
yeah.
In fact, if I would have been there, I could have been black as well. Okay.
Yeah.
Convert the falling temperature into the Celsius, so that can be easily done. I think we have repeating questions. Okay.
Why is this happening?
Okay. So I think the chapter is finished, I think.
Yes, sir.
Let's read this. Now scientists are taking off 5 states of matter. Okay. So here is your question, Adrija. And now see this. So solid, liquid, gas, plasma, and Bose-Einstein condensate. Okay. So whatever you are asking a question, it is given in the book. Don't worry. But it is given in the red color. More to know. So you want to more to know, you can know it. Plasma. The state consists of a super energetic and super excited particles. Like some students are there in the class, like you were super energetic and super excited. These particles are in the form of ionized state, ionized gaseous. Okay, now you must be having some confusion of ionization. So anything that is neutral, we say that it is neither having positive state or negative state. But if there is a lack of some proton in it, it will become a cation or anion. You will come to know this ionization in more detail when we will move on in chemistry. Okay, right now see this. Please understand there is something negative or there is something positive on the gases. Charge. When I say ionized, means I am talking about charge, positive charge or negatively charged. The fluorescent tube and the neon sign bulbs. Okay, you can see those tubes when somebody is standing in a night and there is no light and he wants to just showing the uh, where to go, the directions. There are some police officers, you want to stop something, there is a night marshalling for an aircraft. Suppose the aircraft is coming and we want to call him. Okay, so the fluorescent color that we wear, it's like a parrot color, dark parrot color. So the fluorescent tube and the neon sign bulbs consist of plasma. Inside a neon sign bulb there is a neon gas, and inside a fluorescent tube there is a helium gas and some other gas. Please highlight this, the name of the gas.
So this
Somebody
is not there for
what?
us. This is not there for us.
This is not there for
The
us.
screenshot time.
Okay, this is not in your screen, in your book. Why? Okay, fine.
I
No.
guess they deleted it.
Okay, inside a neon gas. Okay, so please write down. Okay, the fluorescent tube, the name of the gas in the fluorescent tube is helium gas, and the name of the gas in neon. So neon is plasma is neon. The gas gets ionized, that is gets charged when electrical energy flows through it. This charging up creates a plasma glowing inside the tube or bulb. The plasma glows with a special color depending on the nature of the gas. The sun and the stars glow because of the presence of plasma in them. The plasma is created in stars because of very high temperature.
Okay.
Understood? Plasma?
Yeah.
Okay.
We are
Bose.
not having plasma, you have.
It's okay. I will send the book as well.
Okay.
Bose-Einstein condensate. In 1920, Indian physicist Satyendra Nath Bose had done some calculations for the fifth state of matter. Building on his calculations, Albert Einstein predicted a new state of matter, the Bose-Einstein condensate, BEC. I told you, Adrisha. Okay, so a scientist can name a particular thing on his or her name. So once you become Adrijanian plasma or Adrijanian 6, we can learn it. So Albert Einstein predicted a new state of matter, the Bose-Einstein condensate, BEC. In 2001, Eric A. Connell, Wolfgang Ketterle and Carl E. Wieman of USA received the Nobel Prize in Physics for achieving Bose-Einstein condensation. The BEC is formed by cooling a gas of extremely low density, about 100,000 the density of the normal air. So small. To super low temperatures, you can log on to www.chem4kids.com to get more information on these fourth and fifth states of matter. Wow.
So for kids, that means you're only gonna get games on that and nothing much. I
Yeah.
guess.
Chem for kids.
So NASA's also kids website, nothing is there.
Okay. So there is no photo for Satyendra Nath Bose and Albert Einstein. It's okay. So what you have
So
learned,
can you just sir, can you just scroll up to take a screenshot?
I will send the book, dear. Don't worry. Why you want to take the
Still,
screenshot?
sir.
I will send the book PDF version.
So,
What you
go
have
into the
learned?
PDF.
I will send the PDF in the group.
She is lazy to go through the PDF, sir.
So she wants to have a screenshot only.
Yeah, that's true.
Okay. So let me reduce it to the size so that you can take it fine. Okay. Now is it clear now?
Yes, sir, thanks.
Okay, fine. Matter is made up of small particles. The matter around us exists in three states: solid, liquid, and gas. The forces of attraction between the particles are maximum in solid, intermediate in liquids, and minimum is gases. The forces of attraction. Now, the spaces in between the constituent particles and the kinetic energy of the particles are minimum in case of solid, intermediate in liquids, and maximum in gases. The just opposite. Force of attraction is more in solids, but minimum the particles of kinetic energy is minimum.
Yeah.
The arrangement of particles in most ordered in the case of solids. I mean, it is ordered, okay? It is placed one after another. In case of liquid, layers of particles can slip and slide over each other, while for gases there is no order. Particles just move about nashe mein randomly. The states of matter are interconvertible. The states of matter can be changed by changing temperature or pressure. Sublimation is the change of solid state directly to gaseous state without going through the liquid state.
I can't see
Deposition.
the laptop now.
Deposition is the change of gaseous state directly to solid state without going through the liquid state. Boiling is a bulk phenomena. Particles from the bulk of a liquid change into vapor state. Evaporation is a surface phenomena. So what is the difference between the evaporation and boiling? So boiling is a bulk phenomena.
Yes, so well, evaporation is just occurs like below
No,
the
it is
boiling point.
written. Evaporation is a surface phenomena. It is happening
Yes,
only
sir.
on the surface, not below the surface. Particles
Yes,
from the
sir.
surface gain enough energy to overcome the forces of attraction present in the liquid and change into the vapor state. The rate of evaporation depends on four things. Okay, depends upon the surface area, temperature, humidity, and wind speed. Apart from the humidity, on every case, the increase in wind, temperature, or atmosphere surface area, the evaporation is increasing. Only in case of humidity, it is opposite. The humidity is increasing, the evaporation is decreasing. Evaporation causes cooling. Latent heat of vaporization is the heat energy required to change 1 kg of liquid. 1 kg of liquid, not any amount of liquid. 1 kg of liquid to gas at atmospheric pressure at its boiling point. Latent heat of fusion is the amount of heat energy required to change 1 kg of solid into liquid at its melting point. Temperature, unit, Kelvin, length, meter, mass, kilogram, weight, Newton, volume, cubic meter, density, kilogram per cubic meter, pressure, Pascal. Convert the following temperature to the degree Celsius. Tell me first, First one is 20 degrees Celsius. Second one,
That'll be 197
okay,
degrees
very good.
Celsius.
Convert the following temperature to Kelvin. What about the first one?
298
Very
degrees
good.
Celsius.
Next one.
And
See, Sanvi is going to mark it 100, right? I'm
No,
sure.
sir.
No. I am sure that in the
646.
examination, if there is more option, you are going to just mark 100 because you know 373. Okay, 100, 273.
so 646 I'm getting.
No,
Very
sir.
good. 643, 646 Kelvin.
Wait, so sorry, it's different. 746, I guess. I'll just do it
Come on, it's not 7.
How fast are you doing?
Oh, right, yeah, I forgot.
Give reason for the following observations. So we can give the reason here. Naphthalene balls disappear. Naphthalene is a substance
Sublimation.
which directly changes from solid to gas on heating by the process of sublimation. So the naphthalene balls disappear with time as they sublime due to the heat of surroundings.
Surrounding.
The smell of aroma of perfume reaches several meters away due to the fast diffusion of gaseous perfume particles through the air. Arrange the following substances in the increasing order of the force of attraction between the particles. So first we can keep as sugar,
Oxygen?
water and no increasing order. So oxygen, water and sugar.
Okay.
Oxygen is less because it is a gas. What is the physical
Water
state
is-
of water at 25 degrees Celsius? So it is a liquid. 0 degrees
Yes.
Celsius can be solid, can be liquid. 100 degrees Celsius can be liquid, can be gas.
Gaseous.
So they are telling liquid or gaseous state, transition state.
Yeah.
Give 2 reasons to justify water at room temperature is liquid because the force of attraction between
The
water
particles are less.
is a liquid. At room because it has a tendency to flow. Okay, it takes the shape of a container. Come on, yeah, this should not be the answer. A liquid
Actually,
is a liquid
that
because of the force of attraction between the particles is higher than that of a gaseous, and it has a tendency to flow. That you can say.
So they have given the second grade answer.
Yeah.
Secret
It,
answer.
it takes the shape of the container.
So
So
it
like
is-
as in second grade we used to write that.
No, it is like the movie किसी का भाई किसी की जान, the third grade movie. The answer should be like that of a Pathan or Tare Zameen Par or Three Idiots. Okay.
Yeah.
An iron almirah is a solid at room temperature because its shape and volume are definite. It is hard and rigid. Yeah, this can be created. Okay,
Yeah.
density is high. Okay. So it shows the property of the so
shows the property of
which
solid.
property of a solid, property of a liquid. Okay. Why is an ice at 273 Kelvin more effective on cooling than water at the same temperature? So ice at 273 Kelvin has less energy than water, although both at the same temperature. Water is having additional latent heat of fusion, hence at 273 Kelvin ice is more effective cooling than water. Okay, so this is a question and we have read this as well. What produces more severe burns, boiling water or steam? Okay, steam causes more severe burns than boiling water. Okay, you don't get carried away and just burn yourself with both the cases and experience. Try to experience. Okay, no need to experience. You can learn from
Yes,
the
sir.
chemistry.
So seems like something I would do.
Yeah, Trisa would do
This
that.
on me.
The reason is that
I
it
am not.
releases. So what is the reason? The reason is that it releases the extra amount of heat, that is latent heat. Okay, so latent heat is going to cause the burn. Come on here, that boiling water can cause the burn. No need of latent heat, which it has already taken during the vaporization. Okay.
There's no sense in this answer.
No, they are asking more severe burns. So both can form the more severe burns. So it can form the
When a
blister
hot
as well.
water when a hot boiling water can fall in our hand, that time also it will burn, right?
It will become a blister, and there will be a hot boiling water in the blister as well.
Yeah.
Name A, B, C, D, E, F in the following diagram shown the change in them. Okay, A
So you
melting
talk
or
like you
fusion.
have actually experienced that blister thing.
What?
So you talk like as if you actually experienced a blister
Yeah,
thing.
I do have.
Really?
Yes,
Oh.
So when we do firing, in a hot summer day, what happens is sometimes we are in a t-shirt. So when we do firing, the empty case that is coming out of it is too hot, and somebody putting his cap and taking that into the cap. But if it falls down from the cap and it is not holding properly, that will touch our screen here, and this is a very soft skin, and
Oh.
it gets burned out quickly. It will get burned out. And sometimes
Okay.
I used to cook as well. I'm living alone, I used to cook. So when I'm cooking also, there is some, so initially I don't have any idea that water and the oil should not be mixed together, heat oil. So if you put
Oh
it, it
my
will be like
God.
splish 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 splish.
So you
My,
mixed water and
no
oil
no no
together.
no, the thing was that I washed my, that's what we saw, जो बड़ा सा चम्मच होता है ना, it's like,
हाँ.
तो मैंने उसको धोया, मैंने उसको पोंछा नहीं.
Oh,
आई थॉट कि
okay.
ओके काम चल जाएगा. और जैसे ही मैंने उसको डाला, उसमें पुड़ 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 ऐसे साउंड आई. मैंने कहा यार ये तो खतरनाक ही हो गया. ओके. So melting or fusion when solid changes into liquid. B evaporation or vaporization when liquid अच्छा बताओ इसमें क्या आंसर होगा पहले का. सॉलिड जब लिक्विड बन रहा है तो मेल्टिंग बोलेंगे कि फ्यूजन बोलेंगे?
Wait. It is
Fusion.
Fusion.
Wait, so
No, no, no.
अबे
Melting.
अच्छा, इवेपोरेशन और वेपोराइजेशन क्या बोलेंगे जब लिक्विड गैस बन जाता है?
evaporation.
अबे पागल हो तुम लोग. इवेपोरेशन इज सरफेस फिनोमेना.
Vaporization.
बॉइलिंग हो रही है,
Vaporization.
वेपोराइजेशन हो रहा है उसका.
It's vaporization.
Then what is the difference in evaporation and vaporization?
बेटा वेपोराइजेशन में हम
When
गर्म करते हैं किसी चीज को,
Yeah.
तब वो वेपोराइज हो जाती है, जब वो लिक्विड से गैस में कन्वर्ट हो रही है. लेकिन इवेपोरेशन हमेशा होता रहता है.
Yeah.
इवेपोरेशन
Oh.
सिर्फ ऊपर से होता है. वेपोराइजेशन इज लाइक ए बॉइलिंग.
Oh, I see.
वेपोराइजेशन
Okay,
एट
sir.
बॉइलिंग
I didn't know that.
टेम्परेचर. ओके.
Condensation or liquid.
कंडेंसेशन और लिक्विफिकेशन व्हेन गैस चेंजेस टू लिक्विड. बताओ जब गैस लिक्विड बनेगी क्या बोलेंगे?
Condensation.
Liquefaction.
अबे यार तुम लोग
Liquefaction.
So what's the difference between
From a
those
gas
two?
to liquid is liquefaction.
यस.
Then what's condensation?
कंडेंसेशन इज द अपोजिट ऑफ इवेपोरेशन. इट विल हैपन एवरी टाइम.
Yeah.
So these.
लेट
So
अस चेक द
that should be
आंसर.
solidification.
Freezing
my
or solidification with liquid change. I don't know. I'm tired of all this. Let's see the answer.
Okay.
So we don't have the answer
Wait.
that.
Is this a question?
I think
Or
both are
is this
same.
the answer?
No, I think let us see the question first. We
Oh,
directly went
yeah.
to the. Okay.
Okay. No. The question
Okay.
is.
This was the question. Okay. So A can be termed as both melting and fusion, both. Okay. Very
Yeah.
good. तो ये चैप्टर हमने खत्म कर दिया है. ग्रुप में एक एक्टिविटी करने को बोला है इसने. ट्रांसफर.
That is not going to.
तो ये कर
Sir,
लेना.
मैं नहीं करूँगी वो.
मेरा भी मन नहीं है.
Group में क्यों?
मैं बस इस चैप्टर को नमस्कार करूंगा कि भैया बहुत मुश्किल से चैप्टर खत्म हुआ है. जान बचा ली गई है मेरी. तो यूट्यूबर्स के दोस्तों को भी मैं बाय बोलना चाहता हूँ कि बहुत